Okay, let's get started with the video. Hi everybody. So a couple of weeks back I attended the Animago 3D conference in Germany, in Munich, and I was asked to organize a full presentation track, so I invited a couple of people to be part of the show also and also give some presentations. So the full track's topic was basically 3D urban environments, my specialty field. What I tried to do is look at the whole topic basically from different angles via different presentations with completely different topics. So in this video I am going to record show you my presentation that was not recorded back then. So let's get started. Just a note there, I'm covering some of the slides also that I previously recorded in another video. So the topic of that video was art direction versus proceduralism in 3D architecture. So I will link the video down in the description. So yeah, let's start with the presentation. So first of all, just on the administrative side, as I said, it was a whole track. So there's this first slide that shows who was presenting. So part one, that was me. Then after me in part two, that there was Yvonne Muinde from Iqueta Arts. Then on Sunday there was part 3 and 4 covered by Paulo Silva from Weta Visual Effects, and Freddy was a freelancer. Then there was also, not related to the track, but basically a shout out to Mohsin Moussavi from Scanline Visual Effects, who also gave a presentation at this conference about Scanline's work at the Game of Thrones final season, for which they got an Emmy, or won an Emmy, so that's amazing. And then there was also another presentation given by Taysha from Esri about the topic of how to build procedural cities using City Engine. Cool, so the topic of my presentation was challenges in the creation of believable 3D architecture. So let's have a look. So there were a couple of slides and videos showing what Urban Studios is doing, so I'm gonna skip over those images. You may be already familiar with the stuff. So the procedural favela, then historic reconstruction, work on the architecture Biennale, and in general that we are specialists in the creation of urban environments. Presenter, you guys know this guy, so I'm gonna skip also over this part too. Cool. So then the presentation's agenda. We had a couple of different topics, which is efficiency, architectural principles, urban environments, learnings, and then our application at Urban Studios. So, and as always, the timeline is here at the bottom. Cool. So efficiency. As in all creative projects, there's this like triad going where you can do a project, you can do it well, you can do it cheaply, and you can do it fast. So basically you can always pick two, but you cannot have all three. So basically there's a discussion to be had at the beginning where the foundation is laid out, and especially in a quote or so, where you define how are you going to do things and to which level of quality. Then coming back to 3D architecture, how do you model stuff? Do you model it manually via the classic tools like 3D Studio Max, Maya, Cinema 4D, and so on, or do you go the procedural route? Yeah, so usually there's not a really the absolute best way or approach, but it's very important that you know which approach to take and what technically it means to implement that workflow. So I assume you know some of the things about classic modeling, manual modeling, which you need anyway, even for procedural workflows where you're building individual assets and so on. So let's continue and discuss a little bit more in detail the procedural nature of things. And again, this is also part of the other video. So I'm gonna quickly rush through this slide. So parameters, obviously very important. How you define the procedural nature of things: number of floors, number of base floors, number of top floors, ground floor height, upper floor height, then which windows you are using, what the widths are of the windows, what the distances are between the windows, the facade patterns, rhythms, and so on and so on. Also the decor, columns, pillar, and so on. And then obviously the most important one is, this could be like a multiplier. If we can define anything for a facade side, then how do you deal with changing some of these values for other types of facades on the side? And so basically the whole thing boils down to, how do you art direct procedural systems? And this is one of the key points I want to make in this slide, is that the parameter space, so the sum of all of the potential designs, defines the design space. So the challenge number one is, if you are tackling a 3D architecture in general, you need to make sure that yes, you are efficient, but that the main goal, the art, is basically met. So art direction is something that heavily influences, especially procedural systems. And I believe it's one of the more important things, especially if you are working for clients. You need to have the control in place, and not just be able to generate lots and lots and lots of buildings, but also to be able to art direct them. So that was challenge number one. Then slide I have also previously shown in past. Different architectural styles have different elements, like arcs or windows, columns, statues, and so on and so on. And they have to be compatible to each other to form a consistent architectural style. And depicting, or actually constructing, completely different architectural styles procedurally is actually very hard to use, or when you're using only one procedural system. So this is something to remind yourself of. Then the whole notion also of archetypes. So I picked this image here from Fantastic Beast that shows like an archetype of what is a typical building in Paris. So this is something that can be basically created procedurally very, very efficiently, but it lacks a little bit, I would say, and that's also the core of why I added these slides, or why I added this point in the presentation. It lacks a little bit the variety of the different building usages. So this whole area here is residential, with maybe the exception of the very far distant Eiffel Tower and the Sacré-Cœur, and maybe another little church here, but otherwise there are not really a lot of different buildings or building usages that can be seen, like, I don't know, an administrative building or library and things like that. So the key point here is that try to use multiple archetypes. So let's have another look at an archetype, which I think depicts the word really, really well. So it's a very homogeneous structure of an urban area. So you always see the same pointy roofs, the same type of like towers, and so on and so on. So the challenge number two is use multiple archetypes, just to break things up, just to make things more interesting in the sense of general realism of a city. Now let's switch to architectural principles, second topic. So not everybody can have some architectural training or know about the architectural theory. That's completely okay. So let's start with something that I found very, very helpful for me to think about architecture and to design architecture. And this basically goes back to a very famous guy called Vitruvius. He lived around 80 to 70 BC, and he was an author, architect, and engineer. And he wrote 10 very, very famous books called De Architectura, and they were basically one of pretty much the oldest, very, very concise books on construction and planning of architecture. So they had a huge influence over the time, and are still referenced very, very often in the architectural context. Just as a side note, you certainly know this drawing by Leonardo da Vinci. This is called the Vitruvian Man. So this is not Vitruvius himself, but it basically mentions Vitruvius as a reference. And the main context is that about the picture is that you see the little square, or the square and the circle, and the human figure that actually is fit into these proportions. So the whole notation about this image is the connection between human beings, their proportion, and the link to science. So what did Vitruvius do? He basically invented a triad, and this is nowadays called the Vitruvian triad, where we have three principles: the venustas, utilitas, and firmitas. Venustas means beauty, utilitas is utility, and firmitas is durability. So architecture should always have these three qualities. Lots of those principles, the mixture or the combination between proportions of the human being and the link to science and where these proportions come from, is something that has influenced architecture heavily. And there's a famous architect from the Renaissance called Serlio, and he studied, or especially got famous for his work on columns and the column orders. So we see them here. There's the Tuscan order, Doric, Ionic, Corinthic, and the composite. And all of them have very, very specifically designed proportions, sizes, elements, and so on and so on. So, and this pretty much all of the work from the Renaissance goes back to these thoughts of Vitruvius, thinking back of the old Greek times, with the old Greek temples and columns and colonnades and so on. And the same thought continues also with Alberti's work on, for example, the Santa Maria Novella. You see all of the geometric patterns here, and all of the links between the proportions and elements, and everything was rigorously designed using geometric proportions. Now, what Alberti said is, beauty is that reasoned harmony of all of the parts within a body, so that nothing may be added, taken away, or altered, but for the worse. So this is a definition of beauty in general, but especially true for architecture. Now, this is not a hard definition. It's more soft, so it leaves a lot of room for interpretation, and it obviously also leaves a lot of room for different architectural styles. Let's have another one from Plato. Those arts which are founded on numbers, geometry, and the other mathematical disciplines have greatness, and in this lies the dignity of architecture. Again, the same thing is basically trying to build everything on numbers and geometry and try to kind of reverse engineer nature. Let's quickly talk about Venustas, beauty. Beauty and proportion transform dead matter into a higher state of meaning. So by designing architecture, by using construction materials like concrete or stones and so on, what we are doing is we are forming something that has a higher meaning to us than if the elements would just be scattered about, like rocks lying somewhere in the mountain or something like that. We are building something that is of high meaning. So coming back to the entertainment industry, where everything is about the story, and where we are going to is that believable architecture has to sell a convincing story. So challenge number 3 is architecture is an actor. Architecture in a movie or in a game cinematic or in general in the entertainment industries is something that allows you to tell the story. So it's a silent actor. Beauty and proportion, basically, not in the sense that the building has to be beautiful in the classic sense, but basically it has to fit the narrative. So it can be destroyed buildings, it can be utopian or dystopian types of architecture, but the styling, the design has to underline or stress the story's narrative. So challenge number 3, architecture is an actor. Let's have a look at some architectural styles. So this is Art Nouveau with lots of very, very natural flowing forms that are inspired by basically nature and leaves and growing vines and so on. So what's an application of something like this in the entertainment industry? Well, it's very, very clear that this architectural style was the base for the inspiration of for Rivendell, or in general the elvish architecture that we see in the Lord of the Rings. And on the other hand, what we see below here, this part of the slide, is Erebor. That's basically a dwarven city that is also inspired by a different but very specific type of architecture coming also from our world, which is called Art Deco. And that's actually very interesting to see that, let's go back to Art Nouveau inspired the elvish architecture, while the dwarven architecture was directly influenced by Art Deco. Sweet, so let's talk about firmitas. Let's go a little bit into math, but not too deep. So if you think about a beam that is held on one side and on the other side, and you're pressing down or you're applying some force Q in the middle of the beam, so what you will get is some displacement. So that basically means the beam will bend. And this W value here, basically the yellow line, is how far will it bend. And this basically depends on the force and of the material and the profile of the beam. So this is the mathematical function here. We have Q, L to the power of 3 divided by 48 EI. So let's have a quick look here. Q is the force, L is the length, E is the modulus of elasticity, so which type of material is it. So steel will bend less than rubber, for example. And then I is a value, the moment of inertia. That's basically a geometric value of the profile here. So for example, I or T beams, they have the according form in the form of an IM or a T, as you certainly have seen them before. Now, why do I bring this up? It's actually this L to the power of 3, which is the power of 3 takes the distance and exponentially lets the deformation grow when the width or basically the length is getting bigger. So the length has an enormous input on the or influence on the deformation. Now, what does this mean? This, to me, when I was studying this was actually very, very important to understand that formulas like this, or basically the physical reality, heavily influence the construction of the buildings. So let's have a look. You see a huge skyscraper, and then there are some columns, basically some huge columns, which are carrying the weight. Now, it's not the same setup as we had before with the two base points to the left or right. So it's a little bit different setup. But what's important is that the forces of all of the floors which are coming down, and they are basically combined into these columns that we have here. These forces based on these mathematical equations, they can get so big that the construction actually needs to be 3 full stories high. So the actual point is, if you have a building, you can show an honest construction. So you can show that this building actually has a weight. And this is very, very beautifully shown in this image here. So the construction is super, super thick. And this is basic because the building is enormously heavy. Now, of course, there are some buildings where these details are specifically missing or hidden, but it's one of those stylistic elements that architects sometimes very deliberately show on the outside of the facade to show honest construction of such a building. So let's have a look at the second component of the honest construction of a building. What you see here in this second reference image of a skyscraper is that we have these black parts which are 3 stories high. There's one up here, there's one up here. So, and the distance between them is like about 30 stories or so. So what are these black parts? They are 3 floors entirely filled with machinery, just to support the rest of the building. So there are heat generating machines. There are water treating machines. There are electric motors for elevators, and so on and so on. So there's absolutely nothing else in those buildings or in those floors than supporting machinery for the rest of the other floors. And there are some physical reasons behind that. Now the black parts here in that case, or also in lots of other cases, they are actually opened like vents or grates, so air can flow through the building. So it's kind of these black areas or these black designed floors, they're basically kind of the lungs of the building. So challenge number 4, more engineering. The point here is that when you are designing a building, it's very, very helpful to show honest constructions and honest details that also add to the life of a building. So go in, and when you're creating a building, show some of these engineering parts, not engineering parts, but go in and show some of these floors that actually are like the technical backbone, so that the building can actually work. Utilitas. We've discussed before with the archetypes and procedural modeling that a building can, and also in the context with the whole discussion of Vitruvius, that a building can have or should have a specific utility. So if you're designing a building, like for example this, well, it could be more like a city, it could also be a building, it's an abstract thing, but what I want to say is, if you're building a form or a volume that should represent let's say an urban space, what are the usages that are going in these forms or in the environment? So if we assume that, for example, this structure here is an entire gigantic city where, for example, the dimension here of this part is, let's say, 10 floors or so, think about it. What would the different usages be for each volume or even per floor? Would it be residential? Would it have landing zones for flying vehicles? Would it have some I don't know, some hotels? Would it have some technical rooms and so on? So the utility is very, very important, and this can be derived from the story that you are telling. Whichever city you are designing or urban environment you are designing, whether it's in the future or in the past, there are always needs for different types of rooms, different types of building usages. So let those influence the design of the environment. Urban environments. If we are going from architecture or from an individual building to an environment, there are lots of different elements that are added. So a city is never just the sum of all of the buildings. So there's lots of things that are added on top. So there are parks, nature, cars, I don't know, airplanes, and so on and so on. So an urban environment lives off lots and lots of different elements. Now, in our studio, we are starting to build up a library with different elements, starting with the architectural details like solar panels and doors. But we are usually going further, and this is something that is another one of those challenges that are core of this presentation, is how do you tackle the creation of believable architecture or believable environments? Well, by looking at some of the statistical components of an environment. So when I created this project with my friend some time ago, we deliberately looked at reference images and started to count different elements. Which types of 3D elements do we have or did we have to create? Like water pots, AC units, trash piles, cables, and so on and so on. How many plaster walls are there? How many brick walls are there? Or if there are brick walls, are they gray brick or red brick? And so on and so on. So the statistics are very, very important to tell which type of story, or to underline the story that you are telling. So challenge number 5 is check the statistics in what the story you are telling is actually about, and then choose the most important elements and add them to the 3D representation of the environment. Okay, and then last challenge number 6, add politics. So politics are something that heavily influence an environment in the sense of the architecture, but also in the sense of the whole climate. So how much dust, how much smoke and haze and so on you have. So there may be stories where where humanity has learned, or an alien race, whoever has learned to control the weather and so on. So in this example, it's one of the best examples I could find from the movie Dread. You see that the very, very strong grime on the buildings, and this enormously dense dystopian architecture here, with these skyscrapers where the people are living, and yeah, the whole political aspect of the environment that we see here is something that I believe is very, very important to very deliberately design. So the more extreme, obviously, you go with extreme skyscrapers, and you think about what would it mean that if I live down here where there's enormous amounts of dust collecting or aggregating, or also, for example, if there's no daylight because I'm living in the shadow of one of those huge structures. So these thoughts are very, very important to me when I design an environment. Think about the politics. Okay, let's talk about the learnings. First learning: art is more important than efficiency. Choose the right tools to make the best out of your time, and don't go for the most technical workflow, but go for the one that is most straightforward to sell your story. Second one: use multiple archetypes. This is important to me, just to break up the urban fabric in something that looks more realistic. Architecture is an actor. Use architecture to sell the story with subtle hints in architectural style, in how grimy the architecture is, in how polished, or how futuristic, or how well it is maintained or constructed. Use all of those things to support the story. Number 4, add more engineering, add more vents and pipes and constructional pay attention to the constructional dimensions. 5, check the stats. So basically go in and count how many different types of AC units you have. Check how many different types of materials you have. Check what the color palette is, and so on and so on. And use those statistics to drive the creation of the art direction and also the architecture and the environment in 3D. And then number 6, add politics to bind everything together in a continuous or in a consistent universe. Okay, application in our studio. As mentioned before, we have started to invest a lot in our own libraries and improving our internal workflows and how we create 3D architecture. So we are heavily focusing on this for now and for the future. And for our clients, we are trying to provide something that is the best combination of efficient modeling, procedural architecture, but also manual art direction, to basically support our clients with the task of engineering basically the creation of large amounts of buildings within consistent 3D environments. And for this, we're developing our own tools and contents, and even technologies that, for example, create multiple levels of detail based on exactly the same building. So if you compare here, you have the high quality building that is, for example, compatible also to game engines, but it could also be one-to-one be used in visual effects. There's like lots of polygons, 63,000, and then we continuously go down with the level of detail to something that even has just 2 triangles, so that's basically just one card or one plane for the very, very far distance, if you then need some levels of detail. So this is something that we are heavily investing in at the moment, and that will have lots of very interesting applications for us and potentially also for clients. Then, speaking of clients, I'm going to show a couple of images from one of the last projects we made for Urban Games for this PC game, where we created over 500 3D buildings, and this is how it looks in-game basically. So the simulation and so on is all provided or created in-game by the game developers, but we provided all of the 3D buildings using our very art directable workflow. Okay, there's not going to be a Q&A in this video. I really hope that you liked the presentation, that it was inspiring to think a little bit more in an architectural way, also regarding the different challenges which I mentioned in the presentation. If there are some questions, let me know or let us know down in the comments or send us an email. I hope you liked the presentation and see you guys in the next video. Thanks.